Recording in progress. All right. So let's go ahead and start our test 2 review. The first part is properties of addition and multiplication. So name the property illustrated by each of the following. So we know that any number 0 added to any number is the same value as that number. So this is the identity property of addition. All right, what about B? What have we done here? Right, we just flipped the parentheses and the variable on the outside, the 6. So what do those parentheses mean? I mean, obviously, there's an operation inside, but we can't simplify inside the parentheses because those are unlike terms. So what have we done? So, okay, yeah. Close. The distributive property would have been if we actually multiplied the 6 times the 5 and the 8. Because we didn't, we just moved them around. So what do we call it when we move around the terms that we are multiplying or adding? No. Remember, what does it mean when you drive? Commutative. I'm sorry, everybody else is yelling. I couldn't hear it. So this is the commutative property. Now, this is the commutative property of multiplication because it's the multiplication that's being moved around, not the two numbers being added together, or excuse me, the two terms. All right, what about C? Associative. So remember, associative, and you know whether it's associative if you can look at it and you have the numbers are in the same order. So this is 4, 3, and 7. On this side, it's still 4, 3, and 7, but we have changed the order of operation. So this is the associative property of what? Right, this is all multiplication. So the associative property of multiplication. All right, what about D? Again, look at our numbers. We have 4, 7, 8, 8, 4, 7. So are they in the same order? One's 4, 7, 8. The other's 8, 4, 7. No. So what have we changed? This is commutative. The order of the numbers has changed. The order of operation has not changed. The negative 4 plus 7x is still in parentheses. So if they gave you a value for x, you would be solving inside the parentheses first. So this is commutative. Yeah, but this is the addition. All right, what about E? Distributive, very good. D-I-S-T-R-I-B-U-T. I just have to spell that. Like I always miss a T or an I in there somewhere. Distributive property, and we don't have to specify because distributive property only happens with multiplication. You distribute to every term that is separated by a plus or minus. All right, what about F? Associative. Let's see, what have we changed? So we have a 3, a 6, and a 2 here. We have a 3, a 6, and a 2 here. So have they changed order? Yeah. What has changed? Order of operation, but they have not been moved around. They still are in the same order, 3, 6, 2, 3, 6, 2. So this is your associative. So again, just you can think about it like on the left side, it's the 3x and the 6 that are associated together. On the right side, it is the 6 and the 2 that are associated together. We've changed that. So the associative means you change the order of operation or you change the ones that are associated together. And you can see in this one that makes sense because 6 and 2 are both constant, so you could simplify those. So you would want to solve or simplify or associate those two together first. But yeah, the associate, and this is why I have to spell it T-I-V-E, property addition. Very good. All right, what about G? What is it? I don't know. Identity, but which one? Yeah. Well, I don't have, there won't be any inverse on the test, but yeah. Yeah, the inverse, we don't have anything 9 plus -9 or any numbers times their reciprocals. All right, what about H? Does the order of operation change? It's commutative, right? Look at your numbers. One says 2, 3, 4, the other one says 2, 4, 3. So commutative property of what? Yeah. Nah, you'll be fine. Just look for examples. I've tried to find some that are close. And y'all got this. Okay, so for part 2, you have some practice using the distributive property to write an equivalent expression. So remember, an equivalent expression means it looks different. It may have different numbers, but it actually is, its value is equal. So for A, we don't have any variables. So this is just a nice segue into this. So if I was going to use the distributive property here, then what would that look like? 8 times what? And what goes between those two? The plus sign. Right, like, because this is all constants, we can solve it. But in this case, we're not really being asked to solve, we're asked to write an expression. So in this case, we do the 8 times 7 and the 8 times 6. Also, if you ever had a problem like this and we're told to simplify, what would you do first? If I gave you this problem and I said solve it, would you do 8 times 7 plus 8 times 6, or would you just add 7 and 6 and then multiply that times 8? Right, 13 times 8. You know, it's going to be 96 plus 8, which is 104. All right, B. So what do we do for B? Same thing. So what would that look like? 3 times 7. All right. Now, can you go ahead and simplify this? Go ahead and simplify it. Yeah, get rid of the parentheses. 15. So 15x minus 21. Yep. Yep, that's still an expression. We've got multiple terms. Bless you. All right, what about C? Yep. And you can put the parentheses, just make sure you take them away when you're done. Right, so we can still simplify the second part, the second term. So we have negative 9x. And then what is negative 9 times 4? Negative 36. And what do we call it when we add a negative number? Well, we're adding a negative though. This is just negative 9x plus a negative 36. So you can just write that as negative 9x minus 36. Remember, if subtraction is the addition of the opposite, then you change the addition to subtraction and you change the negative 36 to a positive 36. And that shows that it's just subtraction. All right, last one. Y times y plus 19. Okay, hold on, let me pause this. No.
Recording.
All right, so what would this, so Zachary, what would this look like when we distribute? Just baby steps. What am I multiplying times each other? Y and Y plus Y times 19, yes, which would become 19Y. All right, so make sure y'all writing this as we go, right? So what is Y times Y, Zachary? Right, and what do we call an exponent to? Y squared, and I'm trying not to like put my hand down on word because it totally freaks out. So anything times itself is that root number squared, in this case, the variable Y. And then you've already stated that we write 19, Y times 19 is 19Y. And so that's it. Good job. Okay, so now let's actually solve them. So evaluating expressions. Please make sure you work this out. Don't try to do it all in your head. That's where you'll make careless errors. And remember, it's better to be right than it is to be smart. So take the baby steps if you need it. All right, minus a 12. No. Well, it is that kind of Monday for sure. All right, so you plug in the values for A and B. Also, even though you do know that any coefficient, in this case 2 times a variable, is always multiplication, it's still important when you plug in the value of a variable, use parentheses so you don't miss any negatives. Excuse me, yeah, the yawn. All right, so 2 times negative 7. Very good. Negative 14 minus 12. All right. Are these like or unlike? They are like. So what do? We add them. And are they positive or negative? Yeah, they're negative. If you want to make sure they're like, then you change the subtraction to addition. You see they're both negative. 14 plus 12 is 26. So negative 26 is our answer. Easy peasy. All right, so our next one is 5 times m minus 7n. So do y'all want to distribute first? Okay, so if we distribute, what do we end up with? Oh, nope. If you distribute the 5, we got to distribute it to both. So let's keep the variables for a second. 5 times m minus 5 times 7, 35n. And now we can plug in m and n. So this is 5 times negative 2 minus 35 times negative 6. All right, so now when I simplify, what do I get? So 5 times negative 2 is what? Negative 10. Minus, which is 30, carry my 3, 210. Negative or positive? Negative 210, which means what? Right, negative 10 plus 2. Excuse me? Close. But not quite. Are these like or unlike? Well, they used to when we were subtracting. But remember, you must change it to addition before you decide whether they're like or unlike. 200. So you can also rewrite -10 plus 210 as 210 minus 10, which is 200. All right. All right, number 3. So division. So just plug these in. 5 minus what? Which is, right, 5 minus 11 divided by 3 times 1. All right, 5 minus 11. Are these like or unlike? So what do you have to do? Yeah, so you have to convert it into addition before you decide whether it's like or unlike. Is it? -6 divided by 3, which gives me what? Very good. Yeah, okay. All right, next one, 19 plus 5 times. -9 minus 5. And y is positive, so I'm not going to bother with the parentheses. All right, what do you do next? Take care of that multiplication. What's 5 times -9? -45 minus 5. All right. Want to go ahead and combine like terms? What are my like terms? We could do this either way. But this is -45 plus a -5. Right. Four minus 1 is 3. All right, so -31. We all agree?
We only agree if you do that work.
Only if it's right? All right. Yeah. All right, number 5. What does my problem look like when I plug in my values for x and y? 5 times -3. All right. All right, so 8 times -3. 8 times -3 would be -24. And 5 times -3 is -15. Like or unlike? Like. So what's my answer? Right. 24 plus 15 is 39. So my answer is 39? -39. Remember, when you are adding like terms and they're both negative, go ahead and carry that negative sign to your answer bar. That way, when you add the 24 and 15 together, you're going to get 39. And if you don't catch it, you'll just pop that 39 in there and be wrong. So have the negative already there so you don't make that mistake and forget it. All right, so what does my problem look like when I plug in? -20 minus n is positive, isn't it? Well, so it would be plus a -5. Okay. Wait, what? You got 35? Okay. Right. All right, so when you make that negative positive, we just skipped a step there. 20 plus 5 is 25, but they're both negative, divided by 5. All right, and what's my answer again? Negative 5, right? A negative divided by a positive gives us a negative.
Let's do the rest Thursday. Yeah.
All right. So simplifying expressions. It hurts. We've only got through one page, haven't we?
Yeah.
Oh my goodness. Yeah, this is a lot, but it's a lot of practice. The test is not nearly as much as the review. But it's promising seeing how much y'all do understand. Did I start? Okay, good. I was like, I really hope I started recording again. All right, identify the terms, constants, and coefficients in the following expression. So what are my terms in A? Okay, give me one, Julian. The whole thing. Okay, there's one. Isaiah, what's the first term? Okay. And Zachary? What's my last term? Just 9. So which one of these terms is my constant term? 9 is my constant. What are my coefficients?
3, 5.
Yep, I got a 5 and I've got a 3 or negative 3. You can put it either way. I do like for y'all to carry the sign with the term, but I hope you don't. Okay, what about B? What did I do? Boy, I'm not allowed to make these so late. That's actually, that's supposed to be a negative, not an equal sign. So yeah, yay for me. I wonder, here we go. Minus, there we go. All right, either way. Go away. Trying to get my keyboard to go away and I won't. Are you kidding me? Like I use it one time and all of a sudden. Okay, there it's gone. Okay. All right, what are my terms? Sorry. A. A. 5AB. And we'll take we're going to take the sign with it. Okay. What's my constant? What does a constant mean?
It's all by itself.
No variable. Do we have a term with no variable here? A is a variable. If it doesn't have a number, or excuse me, oh, I said that back. If it doesn't have a letter, it's a constant. So this one has no constant. No constant term. Trick question. Okay. What are my coefficients? What's the coefficient of A?
5, 7.
Or
5.
-7.
Yeah.
Guys,
Yeah, get it right.
All right, remember if you have no number in front of a variable, your understood coefficient is always 1. All right, so let's simplify. In 5x, 5 times x plus 8 plus 2 times x plus 10. Julian, what do I need to do first?
5x plus 8.
Uh-oh. Okay, settle down, please. I am recording. I have to distribute. When I distribute that 5, what do I multiply the 5 times? And what you multiply the 5 times every term inside the parentheses. So the 5 gets multiplied times 8 as well. Yes. So this becomes 5x plus what? 5 times 8, which is what? There we go. All right, and the 2 does the same thing with the x plus 10. So what does this become? Plus 2 times 10. 2 times 10 is 20. Nope, just the 2. All right, so what are my like terms here, Julian? So I've got a 5x plus a 2x, and then I've got a positive 40 plus a 20. So we use the commutative property to put like terms together, 5x plus 2x plus 40 plus 20. And now we can combine like terms. So 5x plus 2x is what? 7x, and 40 plus 20? 60. So 7x plus 60 is our final answer. Get that written down. You got it? Yep. All right, Isaiah B. What do I have to distribute here? Y. So what do I get? And what goes between them? Yep. Because the y is positive, all the signs from inside the parentheses stay the same. All right, and the rest of it plus 6y. Very good. All right, like terms, 2y squared and write them, right, use your commutative property to write your like terms together. Okay. Nope, the term stays the same. We're not multiplying. So you don't change your exponent. That's why we can only add and subtract like terms. So this is just 2y squared plus 1y squared, which is 3y squared. Yep. And the other one is negative 4y plus 6y. Negative or positive? Right, the 4 is smaller. So our final answer is 3y squared plus 2y. So you only look at the variables and exponents when you are determining what your like terms are and what you can combine. After that, you ignore the variables and their exponents and you just combine their coefficients. So for example, with this one, I'm just going to show you so you can see what I'm talking about. 2y squared plus y squared. So I'm going to factor out my y squared and add my coefficients. So I'm take out the y squared and I just have 2 plus 1. That's where I get the 3y squared. And then when I have negative 4y plus 6y, I have a like factor here with the y. So I take the y out and I end up with negative 4 plus 6. So this gives me 2y, and that's where I get my answer from. All right, that was B. For C, here we go. All right, so for C, Zachary, this one's yours. What do I do first? Okay. What are you distributing here? But you're distributing a -3. This is where you have to take the sign with you. Because this is, I'm gonna keep this a plus and I'm gonna do -3 times x. And then a -3 times a -y. I don't know if that makes it better or worse. Essentially, when you have a subtraction in front of the variable that you have to distribute, well, yeah, because there's a negative and a negative. So -3 times -y is what? Right, a negative times a negative is a positive. So if you can at least remember that if you have a subtraction in front of the variable being, or the term being distributed, in this case, my 3, you multiply the 3 times everything inside parentheses, but you change all of the signs. So you can see, for example, we changed the sign for x from positive to a negative. So it became -3x. We changed the sign for y into positive because it had that subtraction. So that's a -3 times a -y. All right, what are my like terms? Still use it. Right, we have a 4x plus a -3x, or the 3 is smaller, so we know this is 4 minus 3. Right, so when you, it's so wonky, there we go. So we have 4x minus 3x plus 4y plus 3y, and 4x minus 3x is just x. 4y plus 3y is 7y, so we end up with x plus 7y. All right, Julian, back to you. I'll tell you what, we're gonna all work on this one because this one is a lot. So, oh, isn't that fun? Bad dab, abadabba, abadabba. Okay, easy peasy lemon squeezy. It is very confusing. So go easy on yourself and please don't try to do too much in your head. All right, but Julian, distribute the first term for me. What are we distributing? AB plus AD, as I write it the same again. There we go. All right, Isaiah, what about the second term? B times A minus D. Okay, so there's a plus there. So plus BA minus BD. Zachary, last one. This one here? What am I? Yeah, that one right here. Mm-hmm. You can do, yeah, you can do it either way. DA. So it would be BD. It would be good to go and change all of these. Oh, I lost track of that. What was that? BD. Change all of these to the addition of the opposite. Because back to you, Julian, what are my like, do I have any like terms to AB?
Yeah.
Yeah, which one? BA, very good. Does it matter what order they're in when you multiply them? No. If A is 3 and B is 4, then the first one says 3 times 4, and the second one times 4 times 3, which are both 12, which means it's fine. All right, Isaiah, what's my second like term? Anything similar to AD? negative dA, all right? And Zachary, I lost my thingy. There it is. Are BD and DB the same? Yeah, this is negative BD plus DB. Woo! Do you want to write them all the same way, just so it doesn't get any more confusing? I'm gonna make an executive decision and say yes. All right, so I'm gonna combine my like terms here. So I have AB plus AB, so that gets these two out of the way. I have AD plus a negative AD. I can actually write the right letter. So that covers these two. And then I have plus a negative BD plus BD. All right. Well, we're close, right? We've got these two, and these. These are all my like terms. So what's AB plus AB? Huh? Well, okay. What's anything plus itself? What's 1 plus 1? Okay. So what's your understood coefficient for AB? Right. There we go. So remember, this is just something plus itself. So it means there's two of them. What about AD plus a negative AD? 0. And what about negative BD plus BD? 0. So what's my final answer? 2AB. And that's it. All right. So I would like all of that for that. Yeah, let me go ahead and my Annie. Hold on. I gotta quit. I gotta stop. I'm trying to stop the share and it will not let me. Come on. All right, sorry for the end of this video. You guys, I want y'all to, yeah. No, I'm talking to these guys. I want y'all to finish that page and the translating word phrases. Everything but the word problems. I want y'all to do that for homework. Give it a try. While I try to get this.